Scouten. I'm a sales executive at PROSTEP, and today at the webinar we're going to talk about cross-domain vendor-neutral integration, specifically between your design system, TDM, where you store your CAD documents, your PLM system, and your ERP system. With me is Nick Nessler. Nick is a consultant at PROSTEP, and he'll be here helping doing some question and answers. And he's also good with integration and PLM, CAD, ERP, TDM. So, Hi
everyone. If you have any questions, feel free to use the question box to ask any questions that you have, and me or Kaylee will answer them.
All right. So a little bit about today's webinar. We're going to talk about some requirements for integrating these systems. So, what these systems are, and what we should focus on, or what typical focuses are for the systems. Some possible integrations for designs and strategies for designs. So that could be how to carry over native CAD. And things to look out for in moving CAD data to your extended enterprise. We'll talk about some project planning, some ROI that you might see from these types of integration to get started with, and then some customer experiences and our OpenPDM platform for doing PLM and ERP and TDM integration. A little bit about PROSTEP. So we are a vendor-neutral company. We were started about 24 years ago out of a consortium in Europe. And this is a consortium from the automotive partners at the bottom. And what they needed to do was make cars cheaper back then because they were expensive. And so they saw that there was a focus on collaborating with data exchange, and from that consortium, two companies were born. One is the PROSTEP IVIP, which owns about 15% of PROSTEP AG, and the other is PROSTEP AG and also PROSTEP Inc. from PROSTEP AG. The IVIP is a nonprofit standards body that does standardization like Step 242 or PLM services or OpenJT and long-term archiving, things like that, and leads groups to do that type of standardization. And PROSTEP AG and PROSTEP Inc. are the commercial side of that, and we sell commercial software and services to support that interoperability. Something unique to PROSTEP is our ownership, which is down here at the bottom. We're about 10% owned by all these companies and about 15% owned by IVIP and something like that. We are also very vendor neutral, and we've had long-term partnerships with most of the major players in the engineering ERP realm. And so that is Adobe. And Adobe, we have a 3D PDF generator product and a PDF Pro product that we work with 3D PDF translation for. But you see Dassault, PT, Oracle, SAP, Siemens, all long-term partners of ours, and we support our products with their help. So our products go through and are certified by these vendors. So let's start talking about some requirements for integrating engineering systems. So a little bit about definitions. In order to explain, I think better and have a good understanding of what we want to talk about today, we want to talk about what these things are. So first, TDM, a team data manager. I would call like maybe an older document management system for CAD, like VPM or the old Pro Interlink 3.1 or EPDM, NX Manager, Ideas TDM, things like that. just a system that specifically warehouses and stores CAD data and then has some versioning control for that, right? That could also be in your modern organization, a PLM system that you're using just that capacity for. So you might have Windchill that you're only using for Creo data, or Team Center you're only using for NX data, something like that. A PLM system takes all that concept of a TDM, like the diagram on the right has, with the CAD integration, but then adds to that change control, requirements management, releasing, classification, collaboration, like supplier integration, and configuration structures, effectivities, multi-bombs, all that type of stuff, right? So it contains all that document and CAD control from TDM, but then adding to that more functionality. And then ERP, and I think that's the one that most are familiar with, is resource planning. So that means manufacturing processes, process changes, materials, supply, supplier collaboration, inventory, accounting, and that type of thing. So some concepts for requirements, and I kind of group these into two different requirements, since normally what we see is that in the diagram from the previous, that we see TDM leads into PLM, and there's quite a bit of overlap here with the CAD data being in engineering CAD being driven by the product lifecycle, and then PLM integrates more so than with ERP, with that kind of overlap. And so I separated the requirements between those two to be a TDM and PLM integration, and then a PLM and ERP integration, which is pretty common. So typically what we see for some requirements for use cases between these systems is a synchronization of initial BOM structure. So that could be, in fact, two ways. You could have that your PLM already has an item structure that you know is going to be used within your product, and then you synchronize that structure back in the CAD into the TDM system, and then you go and start your designs from there. Or you then have a TDM system that you have a concept CAD mock-up or structure, and then you bring that into your PLM system when you're through a certain gate, like you want to prototype it, or even if you want to bring it all the way to the release, then you can synchronize that into PLM in order to then do some better change control on it, right? So the structures can come from one or another initially, and it depends on how your organization works, I think, in order to do that. Typically, though, we want to have TDM revision control, status, change control, BOM, all that stuff. Once the maturity of the product hits a release, we want that to be under change control from PLM and then reflected back to the TDM system. So you might have a change that has a new revision of a part. Well, then we go ahead, and after that change is then pushed through, then synchronize that back to the TDM. It'll create a new revision, with a deep copy of the old one, and then it's updated. Changes then processed. You can also do things like loading configuration structures between the two. So if you have an upper level assembly that defines a little bit better your product that you're not going to use within a design, synchronize that from a PLM to a TDM so it's there and visible. For CAD data, we could do natively synchronized data from a TDM to a PLM. So that could be something like on release. Then we want to take that native data and push it to PLM. You could have your TDM generate some derived outputs from that CAD data and push it into the PLM, or you have it exported and generate the derived output outside of that and then put into the PLM. So in the typical situation where you're using multiple vendors, sometimes what you have is you'll have an integrated solution for providing a derived output within that vendor's specific, type of output, like you have VPM and you generate 3D XML or something like that. But you might not have something like a wind chill derived output in here that you might need, like a Creo view. So in order to accomplish that, you would then export that CAD data, CATIA data from VPM, generate a Creo view outside, and then put it into Windchill. And that fulfills the functionality you need in Windchill in order to have that visualization there. When you're using the system, it'll have a proper representation. PLM integration with ERP. Specific requirements for this and use cases would be synchronizing PLM data for engineering parts and BOM structures, manufacturing parts and BOM structures. You could handle that in both systems. That could be, done within the PLM system or within the ERP system. We see it both ways that go back and forth. But typically that starts with the engineering structure, and then that's cloned, and then might be then pushed over to the ERP. Change control certainly goes both ways, and so you're going to need feedback from engineering and from manufacturing about these changes, and this is a big situation for integration. Moving the record of design to ERP, so that could have even come from the TDM and the CAD document derived output, or even the native CAD, and then pushed over to the PLM, and then from the PLM to ERP for better supplier collaboration, other things. And then other types of project planning and documentation. It could be that you're housing PPAP data or certifications or compliance, stuff like that. And you can move that then between these systems. Same thing going the other way. Certainly change control goes both ways, but that's largely cost visibility and process organization that drives that. So it could be that you want to have your engineers get a little bit more visibility with the cost of these products. You can have that synchronized back and have it roll up more effectively within your PLM environment. And then also vendor and supplier information and support BOMs, if you have like an S BOM within the system or manufacturing BOM that can be synchronized back. So one thing that we see within these systems is supplier collaboration is always typically hands-on, right? So you need somebody in order to aggregate this data together in order to actually effectively manage that. And one thing that an integration can do is take all that enterprise data and then focus it so that you don't have someone specifically needed in order to package that, right? So that could be for something in ERP or PLM that you need to define a quote package, right? That quote package might include something like a design, like a drawing package that comes from your TDM, goes to some PLM, you need some parts and BOM data, and then ERP you have some supplier data, right? So if you would maybe synchronize those between those systems, you can gain some efficiency in supplier collaboration. That also might be something like doing some design synchronization, having up-to-date design space for the suppliers, having them directly integrated into your TDM, but the efficiency of driving that BOM structure already from your PLM into your TDM is going to allow that to happen. And also stuff with supplier parts and BOM information aligning to manufacturing. You'll see that supplier collaboration with an integration can be greatly efficiently dealt with, automated in a lot of cases. Another good use case for integration is strategic decommissioning. So it could be that you've adopted this new PLM system that kind of bridges where that TDM and ERP might be, and you want to get rid of that old TDM system. So one way you can do that is to build this integration and then move that data over time and synchronize that data with the PLM system, and then eventually decommission that. So this is a theory we call coexistence in migration, and can be accomplished, you know, with these integrations if you have enough of the use cases that move all the critical data that you need. Over time, you could then have this legacy system kind of be decommissioned, move more users to the new system, to the PLM system, less users on the TDM, and then you know, ultimately just get rid of it and just use one system. Yeah. So we have some surveys here within our presentation, and we want to know a little bit about what you are trying to accomplish here. So first one is, what new system do you want to integrate into your enterprise? And so this is if you have a new system that you're planning on implementing, or if you have you know, an existing system that you want to move in. So it's kind of focused on that. So Nick, any interesting questions do we have so far?
I have a couple that I was thinking of. So if PLM encompasses TDM, what would be a reason for having a TDM and a PLM system integrated with each other?
I think a lot of the reason is with the legacy environment. So it could be that these PDM or PLM systems haven't been completely around for the last 20 years. It's more of a recent phenomenon that you have a more overarching system that can handle all these different cases. And so you probably have a lot of investment in your TDM system, and everybody knows how to use it. And you know, there's already all the solutions have been provided for these because you built them over the years, you know, with that old system, and so you don't want to get rid of it just altogether. And so I think a lot of it comes from legacy. It could also be that that's the best system for handling the CAD data you want to use. So if you're trying to use, you know, NX, I think Teamcenter is probably the best system for handling that data, right? Because the integration is the strongest. And that might not be your preferred PLM system, so you might adopt Windchill or something like that, where they do have strong integrations, but not as strong, right? So then you can bridge, you know, the best in breed functionalities of those two systems, right? So the strong integration for CAD on one, and then maybe, you know, good supplier management or something like that on another. Yeah. Okay. So thanks for the survey, and we'll keep going here. So next, we'll talk about maybe different ways to use CAD throughout your enterprise. And one of the strong reasons for integration is trying to get data, I think, from across the enterprise and from just this silo to be reused throughout other types of silos or other types of places within your enterprise. So there's a couple initiatives recently, I think, that share that idea. So one is, you know, model-based design, master, but ultimately model-based enterprise. And the concept between model-based enterprise is that you want to effectively use 3D models for everything that you are doing, because that's what it's being designed in. And you don't want to have other outputs and drawings or other representations outside of the 3D. So this is a strong initiative. I'm sure most have heard of it. Yeah, so if your VW is not accepting parts in 2018 that aren't in 3D, they want to move, you know, entirely to this type of paradigm, right? So this means effectively that you're going to need, in order to build an integration between your systems to accomplish this. So that could be that your design system, your TDM, or your PLM that you might house designs in needs to then share that those 3D designs with the wider audience. And you know, we're seeing that more and more as a good reason for building integrations. The second is digital thread, and this is something I think specific to GE and a few other companies, but the idea is to collaborate information between these different types of systems so that you have representative feedback all the way across from design to manufacturing and service and repair and in other ERP type of functions. So that could be, you know, in their case they want to digitize most of it, right? So they want to make, you know, virtual design and virtual tests and other types of considerations, but they need that feedback from those different systems in order to populate data so that you can see in the system that you're working with what type of live feedback or integrated feedback you're getting from another one. Something about CAD-derived outputs. So typically, it could be a little bit challenging in order to generate, in order to use native CAD in different systems. So you might see that you're going to export it and zip it up and then put it in, you know, as one blob in the other system, or you take a TIFF or something like that and then publish it in, you know, another system. This might, you know, depend on what you want to, what your intended audience might be. So typically you want to maybe use something like a 3D PDF for non-CAD consumers. So you could also use a PDF or a TIFF or something like that, but the extended enterprise doesn't have access to all those valuable CAD licenses, and they don't know how to use them anyway. So if you're trying to bring that 3D model throughout the organization, you know, 3D PDF is a good way to do that, and we'll see that TDM or PLM data then could be converted into that in order to publish and be disseminated throughout the enterprise for different uses. We also see that JT, CreoView, 3D XML, others are good solutions for visualization integration, right? So the case I spoke of earlier where you have maybe CATIA data from CATIA TDM, in order to make that integration work and make the best out of Windchill, you need to translate that into CreoView. Now, not that CreoView isn't, you know, powerful on its own, or that JT isn't powerful on its own, but it's mostly used, I think, for ensuring that your application has the best benefit. And then also there might be archiving and collaboration situations where you might use a step format. And so step 203 is common. If you're stepping things out, that's probably what you're stepping them out to. Newer versions are like 242. You can use that maybe for archiving and long-term archiving and other types of solutions. But CAD is easier, I think, to handle as a derived output, and it's easier to consume as a derived output than natively, and so this is something you need to think about. The second is doing native synchronization of CAD from TDM to PLM. So the major reasons you would do this is because you want to get rid of your TDM system, and so so if you over time can then synchronize that CAD data back in the PLM, then eventually you'll have all of it, and then you can turn off the TDM. It could also be that you want to have one solution for doing supplier collaboration, specifically your PLM solution, because it's more project-oriented and focuses a little bit more on that. So you could synchronize your CAD data there in order to share and then maybe replicate back down to TDM. And it obviously would have stronger integration with the product lifecycle. And so you can leverage that CAD data to have changes and mock-ups and other things already worked out within your PLM system, one solution to handle all that. But typically it's not very easy to do. So, you know, the integration and versioning and iterations between the different systems, you know, could be different to enough of a change that, you know, these in-work iterations aren't going to be able to be synchronized effectively, or you'd have to come up with a different scheme, revisioning or versioning scheme in order to handle that. It could be that release data, we see that release data pretty much always fits because there's a one revision per version type synchronization. It is performance intensive. You typically want to have processing power and licenses to open it up in CAD, and that could be that you need something like a CATIA PX1 license or a standard modeling license, something like that in order to open it up, do the analysis, and then check it in. And then also possibly the integration licenses for these PLM systems. So if you want to use it within the PLM system, you might need you know, the integration already installed, configured, and licenses for that integration. Typically, you only can move data that opens in CAD, and if it doesn't open in CAD, you might need to do some cleanup. And that means, doesn't mean that it's always the case, but you might have things that were maybe not updated for the latest change, so they're referencing old iterations or old revisions, hopefully not, but it happens. And you know, it could be that things get out of date and don't synchronize properly. And you're probably going to have to handle those on kind of a case-by-case basis. Or, you know, alternatively, you know, there's always the garbage out, garbage in philosophy. You move it as is because you need to do that anyway. But you know, you might be introducing more issues because it doesn't open up and save out properly because it doesn't open up properly, and so we see that that's sometimes a challenge. We do have good tools in order to handle this. So CAD integrations for all these systems, and then also CAD interrogation techniques, and so CAD connectors, things like that. Because we handle this quite a bit at PROSTEP.
Brian, what do you mean by CAD interrogation?
So specifically for integrations and data migrations, we've got tools that could take NX, CATIA, or ProEngineer and look at one of those parts or assemblies or drawings, and then do an evaluation of all the dependencies that might exist for it. And you know, see if those references are available, and you know, being able to evaluate that CAD data, not within a system, but just standalone on its own, right? And so those are what we call a CAD connector, but it's kind of not to do any geometry comparison per se, or geometry, looking at the geometry. It's more of like a metadata evaluation.
Kind of like an audit.
Yeah, exactly. So we know that it's looking for this file, or it's looking for these other dependencies, and we can ensure that those are available to it. Or if they've already been checked into the target system, like we're moving that into a PLM system, we can do the evaluation of that against the PLM system to reuse what you need to reuse in order to check it in properly. Yeah. So we have another survey, and we're wondering a little bit more about, you know, your organization, what CAD systems you're using, and CATIA, NX, Creo, SolidWorks, ECAD, others. Definitely good to hear.
Hey Brian, there was a question about this coexistence between TDM and PLM. How many, can you think of like a proportion of companies that maybe have a TDM system and want to now have a PLM system as well? How many of those tend to adopt this kind of a TDM from one vendor and a PLM from another vendor coexistence thing?
So I think it's pretty common in larger organizations, right? So if you look at like all the aircraft OEMs work like this effectively. So if you look at Airbus, they've got VPM and they've got Windchill that they use as PLM. Embraer, same, right? So they have VPM and they're introducing Windchill and SAP. Yeah. So you're going to see that, I think, more so with companies that have a large legacy of using these TDM designs, and they don't want to just move over in one-time migration to a PLM system, which is also common in things that we do. But they want to be able to slowly move that over because they've got too much invested in their TDM and all their people know how to use that real effectively to just cut over. And they I don't think are going to get away from, and Airbus isn't going to get away from CATIA anytime soon. And so they're still going to use that type of solution. They purpose-built that integration in order to work effectively between those two. Yeah. Yeah.
Thank you.
Okay. Good. All right, let's talk a little bit about project planning and business cases. So some advice on project planning. Typically, we want to phase this project and build on knowledge and success. So, what we'd like to see within integrations is more of an iterative model than a waterfall model. And what you can then do is kind of shorten the development to production cycle and then leverage that understanding and that learning and all that, the stuff that we've already built, and reuse that in different integrations. So you'll see that things like part and BOM mappings get reused all the time. And it might be that an M-BOM or an E-BOM is 50% of an M-BOM and has most of the same mappings, that type of stuff. Target 3 to 5 integration use cases. Could be that you want to synchronize change, you want to synchronize BOM, synchronize parts initially, and then maybe do some iterative pattern on that between 2 and 4 weeks. So starting with the strategy or requirements workshop, get everybody aligned, and then come up with a implementation, requirements and implementation document. Or it could be you're using a task system like a Jira or another software system. Develop these, implement the use cases, run the unit and integration testing, so development type testing, process it through business and user acceptance testing, and then put it out into production. And then once it gets out to the production, you'll see that there's possibly defects. You can resolve those defects in the next 2 to 4 sprints. 2 to 4 week sprints, and have some analysis and continuous improvement from there. So you're going to build on all that success. If you have that, and utilizing the same team is definitely something that we would recommend because you're going to build understanding and competence and teamwork, right? We typically implement within a V model, so something like what's on the right, where you have design, and then you'll have some analysis and implementation, and then testing, and then roll out, right? And if the test is wrong, it goes back to the design, right? So there's a feedback from the right to the left of the V. But I think this is pretty standard software development lifecycle for those who are into that. Some business cases. So why would you want your enterprise to adopt integration? What we see a lot is manual duplication costs. So you can quantify that by each operation that you have to synchronize. So this is specifically somebody that's sitting in a chair and it swivels between one terminal and another because they have to duplicate that data every time they want to do something. And that could be that there's, problems with that because they don't do it immediately. It might take them a week in order to enter that data, and it's not available. There's time that takes from that person who's entering that data to be duplicated to the other system. And then, God forbid, it's incomplete, which is most of the time what we see, or it's inaccurate. If you have an automated system that drives this, it's always on time. It doesn't cost any time from the worker, and it's largely 100% accurate and fulfills 100% of the requirements. So it could be that the incompleteness can be a big part of that. They don't enter all the data, just the stuff that's required for them to create these things, and so you don't have that digital thread, right, that you might normally have if you have a complete integration. There's elimination of software. So the more integration that you have between these different systems like TDM and PLM and ERP system, the less users you're going to need on them because you can replicate the data between those. And so that means that they only need to use one system instead of 2 or 3. Could be that then also that elimination of software could come from a migration. You synchronize enough of that data over and you no longer need that other system. But this is a good business case to do an evaluation of those part-time named users and then maybe help out in eliminating that. So there's other efficiencies, right, like model-based enterprise, digital thread, visibility, that you're going to gain from this, and you can probably quantify that in a business case as well. And then there's the other ones, like, and I kind of group these together at the bottom. Consolidation, meaning that there's only one place to go to for what you're looking for. Increase in data quality, less training, less maintenance, less support needed because you have less users using those individual systems. Less knowledge, right? You don't need to train everybody to use everything, and you can more effectively, you have the same data quality, but more effectively siloed, and so you don't have to use all these different systems. And these are good business cases for integration. So this brings us to our third survey, where you might see your best ROI for the integration. So avoiding duplication of data, decreasing licenses, increased efficiency, reduce complexity. Get some results. All right, we'll keep moving. Finally, we'll talk about PROSTEP tools and some customer experiences with integration. So PROSTEP has 3 different types of products for doing engineering interoperability in total. So the one in the middle that we're going to talk about today is called OpenPDM. The other ones are OpenDXM Global X, it's a supplier collaboration tool, and then 3D PDF generation and animation, and those are for generating 3D PDF documents on the right. And those kind of all intertwine, but today we're going to talk about OpenPDM specifically for integration between these types of systems. So what is OpenPDM? OpenPDM is I guess the leading platform for integration between these types of systems. It has a lot of different connectors from these different domains, and then we could also integrate across different corporate boundaries or across different domains within your enterprise. We use standards. We are, I guess, PROSTEP, and so we see a lot of that. It's very flexible, and it's tailored to the type of integration use cases and requirements that you might have. Overview of what the product is. and we have the standard puzzle piece kind of slide, and we have the middle part is the OpenPDM server, and then we have standard commercial out-of-the-box supported by the vendor connectors for these types of systems. So Smart Team, Inovia V6, and VPM, and Windchill, and Interlink, Team Center Enterprise, Oracle Agile, Autodesk, and Aris. And then also ERP like ILC or SAP, and simulation management. Then also different standard formats, OSLC and other web services we have a connector for, and XML and STEP, and we have a very robust STEP connector. The CAD connectors I spoke of earlier, these are ones for interrogating CAD data that sits on a file system, so that you know what dependencies it might have. And then it integrates well with our 3D PDF generator, so you can get CAD data out of a system, generate a 3D PDF and put it back in or put it into another system. Also our Global X Supplier integration, so you can gather up PLM or ERP data and then collaborate together with suppliers to secure data exchange. You can also use this interface to build a legacy integration. So our connector has a standard interface. If you need to go to your legacy system, we can just pretty quickly complete that interface, and it'll be compatible with all the other connectors that OpenPDM has. And so we can add your legacy custom system to this fairly simply. Typically, big use cases are integration, obviously, where we're synchronizing data that we're talking about today. We also handle linking, kind of traceability between these different systems, migration, which you can accomplish through integration, like in a coexistence or in a one-time migration, and then also partner collaboration, so a direct integration for designs or for metadata that gives your partner the design space that you might have, or vice versa, and do that between different vendored PLMs in order to manage that data more effectively. So overall, the OpenPDM architecture looks kind of like this. So in this case, we have a Team Center and SAP integration, and you'll have the Team Center server. We use this Team Center SOA API, but then also we use other Team Center CAD integrations for getting CAD data in and out. And then in the middle, we have the OpenPDM platform, where you're going to have what we call a federation layer, where all the connectors connect to, and they have the same computational and informational model. This also is where in the middle, your custom business logic goes that you might have, and so we can configure it to run at this time or with this trigger, or possibly, depending on what your needs are, can configure all that business logic in the middle. And then SAP, and we use SAP BOPs and RFCs for integration with SAP. But this is another connector on the other side. All this stuff in the middle runs on Tomcat, and it's pretty system agnostic, depending on what you want to connect to and if there's dependencies for that system specifically. So you don't need any customization in order to run this within your PLM. It has like a huge amount of out-of-the-box flexibility for connectivity, and it doesn't run in any of these PLM systems. You can run it outside, and it is highly adaptable to what type of business logic you want to put into it. So a little bit of the framework on the bottom here. We have these different systems that we have this connector layer. So you might have a TDM, PLM, PDM, ERP, or other formats and file systems. And then we have this federation layer that everything is automated at, and this import, export, worker, and mapping engine that we're using within the OpenPDM framework. And on top, we can have systems trigger it, So you might have a release workflow, right, within your PLM system that says, I need to publish this to ERP. Okay, well then the release workflow would trigger OpenPDM. They would export the data and then push it into ERP. Or something like a third-party workflow engine, Beppel, or you know, a newer workflow engine. Then you could say, oh, my business needs this synchronized. Okay, well then the workflow engine can ask OpenPDM in order to do that. We also have monitoring, very nice administrative administrative system. You can do all the configuration for OpenPDM within that interface. Not really. You can also go to the files directly, but there's no need to. So everything is done through the administrative interface. Example process that you might see, this Teamcenter SAP integration. You might have a Teamcenter client, and then it could be that you configure a process to start in this. So you maybe select the top node, right-click on a structure, and then, you know, when you say that you synchronize this to ERP, then it sends a transaction to OpenPDM to start that. So that then triggers an activity. An activity is something that we process in OpenPDM, this business logic that's configured specifically for what you want to do. That exports the data from Teamcenter. It could be metadata and files. It could be, you know, effectively whatever you need. Does the mapping in OpenPDM. So it takes Teamcenter schema, transforms it into an SAP schema, imports that, you know, with the metadata and the files to SAP, and then finally you have the transaction complete, and you'll see that in the SAP client, or, you know, a message, something to that effect that it's completed. So in this case, you have a trigger that starts it, and then you synchronize the data, and then you have the result. But as you might imagine, you can change this to, you know, maybe a release workflow or another type of business process workflow to have that synchronized whenever you need to. This is effectively the type of integration architecture that we see. So we have a bunch of companies. This product's been around for a long time, probably 15 years, you know, some good customers here. You know, there's some small ones, some big ones, and you know, we are actually more than this. Some of them, because of NDA, we don't have up here. A good customer example of this type of integration is at Embraer. So Embraer uses VPM and SAP and Windchill, and they've introduced in, I think, 2013, they decided to introduce Windchill, and in legacy they use just VPM and SAP, and started synchronizing that through what they called a U-BOM, Universal BOM. So now with the E2, they're introducing a multi-BOM system where they have VPM with OpenPDM, synchronizing engineering BOM to Windchill. Windchill then breaks that apart into a manufacturing and service BOM, and then synchronizes those to SAP. This is you know, all done with OpenPDM being the enterprise integration transaction background there. Some interesting things they're doing there. They have real bi-directional synchronization, or really three-directional synchronization for all this stuff. A lot of it's managed within Windchill now, but we're doing things like generating lightweights outside from VPM, exporting CATIA data from VPM, and, you know, generating CAT products, and integrating that into Windchill, and making sure that this stuff is all up to date in real time. So all driven really in real time. So not like a behind-the-scenes daily synchronization, but as it happens. There's been a small go-live in 2014, and then also recently, or in the near future, a go-live for E2 program.
This system's been designed in such a way to where it has the least impact on the users. So they wanted to make sure that adding the new PLM system didn't disrupt their current development processes that they have going on.
Yep. Good. All right, so do we have any other questions that we wanted to go through?
I wanted to point out that our initial puzzle piece slide that we have there, it shows a lot of the connectors that we have, but it doesn't show a lot of the other connectors that we have.
Yeah.
And also, if there's a system that we don't currently support, it's very easy for us to develop a connector for that system.
Yeah, so we have a lot of other legacy connectors that we didn't put on there, like the old ProInchLink or RTC doors, and yeah, some other stuff, and other ALM systems and other systems. Yeah.
We did have a question about ALM systems where someone noticed that we didn't put any connectors for ALM systems on there.
Yeah.
So I wondered if we can do integration with ALM systems.
Yeah. So we have, integrity and doors, and I think that some of that stuff got replaced. I think they put the OSLC adapter on there. Mm-hmm. Because RTC and the IBM stack is mostly driven through OSLC, and so that's our connector now for RTC. But that actually came from the old, Rational Team Concert Jazz integration, right? That we drove through there. Yeah, so we do have adapters for requirement systems and ALM systems and others. Yeah. That should be on the puzzle piece, but I think got kicked off because of real estate problems.
Right. It was looking pretty complex too. That puzzle piece is getting pretty big.
Yeah. Any other questions? All right. Well, so we have a website, webinarsbyprostep.com, and this is going to get posted up there in a couple of days, and I think everybody who attended will get an email that'll point you in that direction. We'll have this presentation and then also the video of this posted up there. And I'd like to thank everybody for attending, and thank you, Nick, for helping out in this. And, again, if you have any questions or would like to know something more about integration, please feel free to reach out, and we'd be happy to discuss. Thanks again, and have a good day.